All right, today we're going to be talking about average atomic mass. Average atomic mass. But before we get all the way into it, I want to do a quick little recap of parts of the atom, as well as isotopes and isotopic notation. So if you remember from class yesterday, we talked about the structure of an atom. And an atom has a nucleus, and inside the nucleus are things called protons and also things called neutrons. Protons are positive, neutrons are neutral. And then going around the outside on these little things called orbits, which were discovered by Niels Bohr, you've got electrons. So we've got 2 electrons on that one. Got to make everything accurate. And 2 electrons on this next ring. So this is what an atom looks like. Got protons and neutrons in the middle, electrons on the outside. And we said last time the way you tell what element an atom is by looking at the number of protons, which are the positive things in the middle. There's 4 protons, abbreviated as a P with a plus, in the middle of the atom there. There's also 3 neutrons. Just count them. Neutrons is N with a 0 for neutral, and 4 electrons. Electrons are E with a negative because electrons are negative. So that's the breakdown of this atom. And the way we tell what element it is the number of protons, which is equal to the atomic number on the periodic table. So 4 protons is beryllium. You just go look at element number 4, it's beryllium. But really, what we care about today with average atomic mass is the mass of an atom. And we know from last time that there's 2 heavy particles, protons and neutrons. Electrons are super light in comparison, so we don't even really care about them when it comes to the mass of the atom. So from the protons and neutrons, for every specific atom, we end up with a thing called the mass number. And the mass number is the number of protons, which I'm going to abbreviate as P positive, plus the number of neutrons, N with the 0. For this atom, we've got 4 protons and 3 neutrons, so you get 4 plus 3 equals 7. And this atom has a mass number of 7. But the crazy thing about atoms is that sometimes they'll have more or less neutrons. So, for example, this element could have, or this atom could have had 4 neutrons. So instead of 3, over here I'm going to have a 4. And instead of a mass number of 7, I might have a mass number of 8. But it's still the same element. It's still beryllium because it's still got 4 protons. The different numbers of neutrons make it a different isotope. So an isotope has a different number of neutrons. So we've had beryllium with 3 neutrons, we've had beryllium with 4 neutrons, we could have beryllium with 5 neutrons. These are all different isotopes of beryllium. But if you look on the periodic table over here at beryllium, it has this number at the bottom, this 9.012. Now if you look over at the key over here, it says that number should mean the atomic mass, which would, to a normal person, seem like that's the mass of an atom. But what is actually occurring is that this number is the average of all of the atoms of beryllium in the world. So there's some beryllium atoms that have a mass of 9. There's some that have a mass of 10, some that have a mass of 8. There's all sorts of different types of beryllium with different masses. But they condense that using an average into one number that's found on the periodic table. Today we're going to learn where that number comes from and how it's calculated. And to do that, we're going to look at your average atomic mass notes, which are found in your digital notebook or in your physical copy if you're from class. And we're just going to go through them together. So like I said before, the atomic mass found on the periodic table is the average of all of the isotopes of an element that are found in nature. And the first one we're going to look at is magnesium. So magnesium has 3 different isotopes. There is there's magnesium 24, Mg24. That 24 is its mass number. And its actual super precise exact mass is 23.985 AMU. AMU stands for atomic mass unit. And then there's magnesium 25, which has an exact mass of 24.985 AMU. And lastly, there's magnesium 26 that has an exact mass of 25.9826 AMU. These are the three types of magnesium that are found in the world. But one thing we do take into account when coming up with the average is how much of each isotope actually exists in the world. And we use that in percentage form. So with magnesium 24 makes up 78.99% of all magnesium in the world. It occurs substantially more often than the other two types, so we care about it a lot more. Magnesium 25 only occurs 10% of the time, and magnesium 26 only occurs about 11% of the time. So magnesium 24 is going to count a lot more in our average than magnesium 25 or 26. And mathematically, the way to do that is to take the mass of each thing, so mass of 24, and multiply it by its percentage. So we're going to do 23.985 times 78.99. But whenever you do that, you have to move your decimal over 2 places to change the percent into a decimal. So before you multiply, change it over. Otherwise, when you add it up, it's going to be off by a factor of 100. So you've got to do 23.985 times 0.7899, which equals 18.946. So you followed the same process for the other two isotopes. We'll multiply 24.985 by 10%, but first we change 10% to a decimal, so that's 0.1. If you multiply 24.985 times 0.1, you get 2.4985 AMU. Sorry, I forgot to put AMU on the previous one. Always need your units. And you do the same thing once again for the last isotope. So we'll do 25.9826 AMU times 11.01%. But first, yet again, we have to change that from a percent to a decimal by scooting over 2 spots. So this will be 2.861 AMU. Now the last thing you do at the very end, after you've calculated all of these totals over here, is you add them together. Add all of them up. And if you add all 3 of those numbers up, you'll get 24.305 AMU. That's the average atomic mass of magnesium. Now let's check and see if that's consistent with the periodic table. Now, if we go look at magnesium, element number 12, you can see our final result, 24.305. It does match what's on the table. Awesome. Well, now that you've mastered average atomic mass, you can go complete your homework in Google Classroom. Thanks for watching and have a good day.